right, this is a nice long problem. Here we have Kentucky bourbon, usually 90 proof. We're given the density of ethanol and we're given a density of water. So let's kind of identify a few things first. What is the solute? That's going to be ethanol. What's the solvent? Water. So that's going to be solvent. And what's the solution? Bourbon. Bourbon is the solution. That doesn't necessarily mean answer. All right. So we call this ethanol water combination bourbon. All right. So we want to know, what is the volume percent ethanol? All right. What are we given here? Proof. Proof, hope you remember, 2 times volume percent. So 90 equals 2 times the volume percent. So volume percent would be 45%. Ethanol by volume. So we're going to kind of need that. All right. Now, what does this mean? 45% volume per volume. That means 45 milliliters of ethanol per 100 milliliters bourbon. Okay, so that means. All right, so here we're going to have 85 milliliters of bourbon. And that's going to be solution, right? And we want to know how many grams of ethanol. Well, we know, because we just figured out up here, that every 100 milliliters of bourbon gives us 45 milliliters of ethanol. Okay, so now we know how many milliliters of ethanol we have. What's it asking for? Grams. How do we get from milliliters to grams? We use this given density. Per milliliter. Okay? And that is 85 times 45 times 0.789 divided by 100. So 30.2 ethanol ETOH is an abbreviation for it. Next, we want it in molarity and molality. Molarity, that's going to be moles of ethanol per liter bourbon. Molality, moles ethanol per kilogram water. Okay, so it's going to be a little bit tough. All right, so I'm just going to go ahead and use this part that we're given here. You can use it, you can do it with volume percent if you want to. It will work out just fine. But since I already did the math here, let's kind of figure that out. All right, so moles per liter. All right, I know, I just figured out that 30.2 grams of ethanol are in 85 milliliters of bourbon, right? That's all I just said, okay? You can do that using, start with volume percents and get there too. You'll get the same answer eventually. Okay, so do I know how to get to moles of ethanol? I do. There's the chemical formula. Use it on your periodic table. You're going to come up with 46 grams of ethanol is 1 mole of ethanol. So now I have moles. Now I need liters, and I've got milliliters. 1,000 milliliters is 1 liter. All right, so let's go ahead and take that. 30.2 times 1,000 divided by 85 divided by 46. So 7.72 molar. That's really concentrated, isn't it? Okay, so now we want molality. Okay. So this, you can do it several ways, but we need moles of ethanol over kilograms of water. All right. So can I get moles of ethanol? Yes. So let me go ahead and do that. 30.2, you may already have done this already. 46.0 grams per mole. Okay. So here 30.2 divided by 46.657 moles of ethanol. So that's the easy part. Now we got to get kilograms of water. Okay, so this is actually not hard. It's not hard. How much bourbon have I been starting out with? 85. Okay. Now, if it's if every 100 is 45 milliliters of ethanol, how much of it is water? 55. 45 plus 55 is 100. So when you have a 2-component solution, that's easy. Per 100 milliliters of bourbon. Okay, now density, 1 gram, but I don't want grams, I need kilograms. 1,000 grams is 1 kilogram. So let's do that. 85 times 55 divided by 100 and divided by 1,000. So we're going to get a really small number. So 0.04675 kilograms. So now let's put these together. 0.657 moles over 0.04675 kilograms. Divided by that answer, 14.05. Also very concentrated. Last one, what is the mole percent ethanol in bourbon? Okay, so the mole percent of ethanol is going to be moles of ethanol over total moles. So that's going to be moles ethanol plus moles water. Okay, so do I know how many moles of ethanol? Yes. We've already figured that out. 0.657 moles. Go ahead and put it in the denominator again because it goes there twice. So we need to figure out how many moles of water. Well, let's go ahead and convert this back to grams. So just multiply by 1,000. So that's going to give us 46.75 grams of water. Let's use 18.02 grams per mole. Again, you use your preferred molar mass for water. 46.75 divided by 18.02. 2.59. Okay. So again, I'm just using this calculation here. Just multiply it back by 1,000. 1, 2, 3. Move the decimal place over. All right. So let's go with 0.657 divided by 0.657 plus 2.59. 202, but so we need to do that. We need to multiply by 100. So 20.2. Wasn't that one fun?